So last day we have discussed about a specific type of uh, designing pattern using nested for loop if possible. So we have practiced some patterns and there are many more patterns we have. We will discuss it in other class. But today we will discuss something different topic, that is in the program till now the different operators that you have used. We have not yet discovered the different type of operators we can have in a C language. So today we will start with the topic on operators on C, and then we will go in detail about the operators. So if you we will start understanding the operator with a very clear categorization of different operators we can have. So if we start with the C operator, the first operator that will come in our mind, actually used in most of the cases, is what we call arithmetic operator. Now under this arithmetic operator, actually we have several arithmetic operators in our language. Actually most of the operators we have already used. For example, plus, minus, multiplication, division, and these four operators we use very frequently in any programming language. But other than these two, which are still very important, are this. Okay, now what is difference between this plus and minus plus and plus and also minus and minus? This plus actually deals with any addition, a plus b. A can be any value, b can be any value. Similarly for minus, but in case of plus it shows exactly increment by 1. It's not actually addition, you should say it's an increment. Obviously addition by 1, right? So a special case of plus is plus, a special case of minus is minus. Now if we go for the other operators we can have, for example, if I go for the next operator, that will be my relational operator, what we call relational operator. And what are the relational operators exist in C language? If we categorize them again, we will see that it will start from equal. It actually shows the relational operator actually express the actually check the relationship between two different two variables having same data type. So equal means whether they are same. If a equal b, that is the condition if comes. Not only if, actually any condition may come, maybe equal, or maybe you can say it is not equal to, or maybe you can say it's greater than, or maybe lesser than, or maybe combination of greater than and equal to, lesser than or equal to, right? So all these operations are possible. These are all about the relational operator. Now if I extend this operator again, the third category we have is what we call logical operator. Okay, logical operator. And under this logical operator, there are three type of logical operator comes. One is called AND, one is called OR, and one is called NOT. You see, what is logic? So to understand this logical operator, first you have to understand what does this AND, OR, and NOT mean. You see, in general, sometimes when we talk with each other, we express certain condition, and if the condition and the outcome of the condition is always either true or false. That means, for example, if I ask you that whether you will go with me or not for some job, for some work, you may reply me that the if rain doesn't come, then I will go, right? So whether rainy day, whether rain will come or not, this there is two outcome only, either true or false. Either rain come will be true or rain come will be false. Even your outcome, that means you will go, either you will go or you will not. So either you will go, it's true, or it's false. Now in this situation, these are actually what we call Boolean. What does Boolean mean? Boolean means that it works with true and false. Okay. And the operators that can play role between these Boolean variables, if I say that I have a Boolean variable x, that means the status of x will be either true or false, not in between them and not both of them. Nothing is possible. Either x will be true or x will be false. So the operator that works on these Boolean variables are actually called logical operators. And there is a specific logic operation that representing this and or not. So this one is represented by and, this is represented by or, and this is represented by not. Actually these three are what we call basic logic operations. Okay. Now above these basic logic operations, we have many more logic operations that are actually some combination of this and or and not. So that's why those are not called basic. Okay. So now let's see what does this and mean. What does and mean? Let's see. Let's try to explore this and. You see, we can express the logic of AND with respect to a table, and that table we call truth table. Okay. And what truth table look like? Always remember, the minimum number of input that you require for this AND logic is 2, and the output that you will get is exactly 1. I'm saying the minimum number of input. That means the input can be 3 also, can be 4 also, can be anything, but minimum 2. So let's go for the 2 input and logic. If I want to do this and want to make a truth table, the table will look something like the column will represent the inputs and outputs. So suppose that I have inputs A and B. These are the 2 inputs of the AND logic, and say F is the output. Okay, something like this. Now as I told you that A and B both are Boolean variable, and obviously F will be also Boolean variable, and that means it will have only a value true or false, not more than this. And this true we represent it by 1, and false we represent it by 0. So all these Boolean operations are actually dealing with some binary, number system. That is for sure. Now, what are the different combination we can have on this A and B? You see again the binary number system coming. The same point comes that if I want to find the combination of A and B, you can see that both can be true, both can be false. One of them can be true and other can be false, right? So if I start with that, both are false, that means both are 0. It can be, can be 0, this can be 1. This can be 1, this can be 0. And both can be 1. So these are the 4 possibilities we can have, right? Not more than these 4. And you can easily understand why not more than 4, because I have 2 variables and each variable have 2 options. So 2 to the power 2, that is 4. Now question is that what will have in this F? You see, the AND logic say that if both input are true, it says that if both inputs are true, then the output will be true. Otherwise, I'm sorry, just a minute. Otherwise, the output will be false. So you see, if both inputs are true means only this condition, right? Because A and B are the input and F is the output, you have seen. Then the output will be true. That means here the output will be true, that means 1. Otherwise, the output will be false. So that means, otherwise means if both inputs are not true, that means maybe both are false, maybe one of them is false, doesn't matter. The output will be false. So that means output will be false for all these 3 cases. And we express this by equation something like F equal to A dot B. So dot is the AND operation, representing this dot is AND operation. Now this table, this is actually what we call truth table, which represents either true or false value in the output. You see all are either 1 or 0, no other values are present. And you see this particular table is basically used in practical life, very frequently. For example, if you have you may decide a situation that suppose that you have some 2-3 friends, you have some 2-3 friends and you want to go for some hangout, and you are deciding for yourself that you will go if both of your friends go for the hangout, something like that. So basically you are following the truth table of AND logic, that if person 1 is going and person 2 is going, then you will go. So if I say going considering and 1, that means if person 1 representing 1 and person 2 is representing 1, then you will represent 1, something like this. The same logic of AND that is reflected over here, right? Similarly, if we go for OR logic, if I do that, design the truth table again, something like A, again B, so again I have an F as the simple, this is again the input, So if I draw the truth table, say obviously combination will be 0 0 or 0 1 or 1 0 or 1 1, and you see the output F actually mean what it is saying, or, and it says that if at least one input is true, then output will be true. Otherwise, output will be false. What is given? Here the condition is again very specific, that at least one input. So you don't need to check whether both inputs are 1, right? You see, if you check the combination of A and B, you will see for these three cases there is at least one input which is true. If the if all the inputs are true, then also obviously that is fine, because that's beyond at least, right? So that means in these three cases it will be 1. But in this first case there is no input which is 0, which is true, so that means the output will be 0, that means false. So this type of table also we follow in practical life very frequently. For example, you want to go somewhere for say for shopping, and you don't want to go alone, you need some friend, and you have some friends, maybe you have two friends, and you are deciding that if at least one of your friend go for you, I mean with you, then you will go for shopping. So the same logic actually you are following, that is represented in the OR. Means if one of your friends go, if that means if I consider the going for shopping is considered as 1, then if one of your friend possesses 1, then you will possess 1, right? So this one we actually represent, just like in case of or, in case of AND we have seen the dot is given. Here we express it by equation as A plus B. Okay, here dot gives the AND operation, here this plus shows the OR operation. Okay, in a similar way, if we consider NOT, you see NOT is little bit different with other. Before other means this previous two logic operations, because NOT does not require two inputs, NOT require only one input. Okay, so assume that means you have only one input A, and your output has obviously only one output F. Okay, now see, since you have only one input, you can have only two possibilities. That means either it will be 0 or it will be 1, right? And not logic say that output will be just complement, the output will be complement to the input. That means if it is 0, output will be 1. If the input is 1, output will be 0. As simple as that. Suppose that you have some enemy, you have some friends who, some classmate or some people you don't like, and if you want to go for a party, you decided that if that particular person go for the party, then you will not go because you don't want to face them. So depends on 1 or 0 for that A person A, you are F, you are deciding whether what you will go. So just your, that means the presence of that person and presence of your person is just complementary to each other, and that is actually what we call expressed by not. So that means here we say that only, I mean, it is not possible to say that if 2% is not going. So if 2% are coming, definitely another operator will come in between them, and that means if both of them or one of them, right? So if both of them, then obviously AND logic will come. If one of them, then OR logic will come. So if you want to work with at least two boolean variable, that means definitely an operator like or AND will come. But if you want to apply not operator, you must have only one binary variable, right? And we express this not with the help of something like in this way, a complement, something like this. Okay, so this is what uh, the logic of not operation we have. Now, so these are all about the logical operators we have seen. Okay, like logical operator, we have one more thing. The similar type of logic operator that we can say, the next one that we can say is actually, just a minute. What I can say is bitwise operator. Okay, so bitwise operator. Now, what does this bitwise operator mean? Will explain it very soon, but let's see what are the bitwise operator possible we have. That is and, only or only. This is what we call XOR operation. Okay, XOR, X sorry XOR, exclusive OR, a special type of OR, a special type of operation which actually is a combination of and, or, and not. Okay, so we will explain it later. And then some other operator, something like this. Okay, something like this. So these are what we call shift operators. So what does it mean? We will explain one by one. Anyway, so other than this bitwise operator, I have one more operator also that we can say, but don't, due to the space, I cannot write the category of the different type of assignment operator as an example. Anyway, so the last one that we can say is what we call assignment operator. Okay, now assignment operator, I hope from the name you can understand it's for assigning something. So obviously equal to sign will come, and other than equal to, there are some combination of two things will come in assignment operator, something like plus equal to. What does this plus equal to means? We will one by one go through this. Anyway, so I hope among all the operators, this some operators that are already clear in your mind is something like this. This is clear, this is clear, this is clear. You know about all this one, right? And this is this plus plus. Now let's come to this plus plus first. So one by one, let's explain. This plus plus is actually increment operator. Increment operator. Okay. mean, let us take an example. If I have a equal to 5, I'm sorry, not, I don't need a equal to 5. I can simply write that a plus plus, it mean a equal to a plus 1. Now I hope you can understand why in for loop we write something like plus plus, because in most of the cases we know, we have seen that we want to increase the value of the loop variable by 1. If you want to increase the value of the loop variable by 2 for a special case, in that case this k plus plus will never work. You have to explicitly write a k equal to k plus 2 in that place. Okay. Anyway, so now in the same way we have a minus minus also. So minus minus is basically same thing, but it's decrement operator. So a minus minus means basically a equal to a minus 1, as simple as that. Now what is left? So these are two done, and these things already you know, because all these relational operators you have used frequently in your program, and these are basically in most of the cases these are used in a condition part, that may be condition of a if else, if condition is a for a loop, condition of anything, but for some condition these are used. These logical operators we have discussed, right? So now let's take some example of the logical operators. Let's take some example of the logical operators. Suppose if I say that I have two value, sorry, a equal to 5, suppose a equal to 5, and say b equal to 10, and if I say that c equal to a and b, what does it mean? This and b means, this means it is logical and, that is for sure. And in case of logical and, what we have seen, that it follow this truth table, that when both of the input are 1, then only output is 1. Now question is that here the inputs are 5 and 10, so how you will understand whether they are 1 or not? In this situation, always remember one thing, that when computer gets this type of instruction, computer doesn't think exact value of a and b. Computer finds whether this value a and b are 0 or non-zero. If it is a non-zero value, then it is considered as true, and if it is true, that represents by 1. So that means this particular instruction will be considered by a computer something like c equal to true and true, as simple as that. And true means we know that it is 1. So 1 and 1 is 1. So that means if you print the value of c, you will get output as 1, because if both of the inputs are true, then output will be true, which is represented by 1. So that means in this type of problem, if you find a logical operator is given, then don't check exact value of the operands present in that line. Always think whether these two operands are 0 or non-zero. That's important. If it is 0 or non-zero, depends on that, either C will have 0 or 1. As simple as that. Similar thing, if I write, for example, a equal to 15, a equal to say minus 15, b equal to 10, and if I write c equal to a and b, here also this a, obviously a is not a positive value, but I can say a is a non-zero value. So again I am saying whether it is positive or negative is not important. It is important to see whether they are zero or non-zero. So any value which is not a zero is a non-zero value. That may be positive, maybe not negative. That means if you want to do this and if you print C, in this case also you will find output as 1, because A is a non-zero value, that means true. B is a non-zero value, that means true. True and true is true. True means 1. Now to get exact 0 in C, one of this value A or B minus has to be 0. I mean, it can be a situation something like A equal to 0, then B equal to minus say B equal to say 20, and then if you write C equal to, sorry, A and B, then only this C will be equal to 0, because B is a non-zero value but C is a exact 0. So any value 0, any value that is ended with 0 is 0. That's why C will be 0. So this is all about the AND operation of this logic, and same for logic OR. Same for the OR operation, and just same for the NOT operation. For example, I can say that say A equal to 10, and then if I write that B equal to not A, and then if I print B, it will be printed 0, because A is 10. Since I have a not operation over here, that's why this part will be considered as a 0 or a non-zero value. I mean, true or false. False means the A has to be 0, which is not. A is 10, so that means it is true. So that means not true is false. So that means B will be 0. Now to get value B, to get value 1 in this B, A has to be exactly 0, only that is then 1 is possible within B according to this particular situation. Now same thing for NOT. So I hope that I don't need to repeat the situation for OR operation, because in case of logical OR operation the scenario is exactly same as we have seen in case of AND operation, just the logic will be different. That's why maybe the output may change. That's all.